Hey, this is Dr. B, and how about some assistance with the Module 2 assignment? We have a periodic table on the next slide that's going to help us. There it is. And let's go ahead and use that to answer some of these questions. Now, some of these are done for you. And what I'll do is I'll walk through it, and I might provide some assistance with some of the other problems as well. So I hope this is helpful and that you learn something. What is the atomic number for carbon? Looks like C is right here, atomic number 6. How about tungsten? Tungsten, well, you might not know it has the symbol W, so you just have to find it there. It looks like it has 74 protons, atomic number 74. Oh, let's skip down to what element has the symbol Ag? Ag, excuse me, is right here. That's silver. And let's proceed along. Oh, how about this? How many electrons, number 9, how many electrons does nitrogen gain to become like its closest noble gas, neon? Well, that's a good question because it's really the same as asking what is the typical behavior of each element? And they all try to become like noble gases. This is a general rule. As the elements get larger, there's some exceptions to that. But nitrogen is not a noble gas. However, neon is. And neon has 1, 2, 3 more protons. Therefore, as an atom, it also has 3 more electrons. I guarantee you nitrogen will try to gain 3 electrons. Therefore, what will it do? It'll form a -3 anion since electrons have a negative charge. So that would be the answer to number 9. I'm not going to type it in, but I hope that helps you. Let's do one of these. Oh, I don't know. Let's see. How many protons and how many neutrons does this isotope 12 and 13. Given that the mass number for carbon is 13, I see. Given that the mass number for carbon is 13, how many for this particular isotope? You have an atom of carbon, it turns out it's mass number 13. Therefore, how many protons and how many neutrons does that isotope contain? Well, going back to the periodic table, if it's atomic number 6, and it is, that means it is 6 protons, end of story. That number defines how many protons that atom is, and that's how we define elements, by simply how many protons it has. The atomic number also includes neutrons, so I think it has 7 neutrons. The answer to that question would be 6 protons, 7 neutrons. I'm going to do 13 as well because it might help. Hydrogen has 2 naturally occurring isotopes, hydrogen 1 and hydrogen 2. What is the symbol for each of these isotopes? H-1 and H-2. That is called hyphenated notation, which I prefer. There's also a box notation. Let's not bother. Moving on to the next slide. Let's see. Number 17 says, and I think I'll help you set this up. Find the average atomic mass of silicon following isotopes and abundances. We got silicon 28, 29, and 30. Now, their masses are very close to 28, 29, and 30, but we've got some precise numbers here, so fine. And it's almost all silicon 28. Therefore, its molar mass, its average atomic mass, will be very close to 28. And here's how you're going to do it. You just set up the abundances times that mass, and you sum them up. So listen to these words, and I hope this helps. 0.922 times 27.977, there's the first one, plus 0.047, right? Be careful with your decimal places, times 28.976, plus 0.031 times 29.974. Should equal the average atomic mass. You better get a number pretty close to 28. Don't forget your units, AMUs, or if you prefer, grams per mole. Let's do a couple more. What is the electron configuration of oxygen? Well, let's use our periodic table to find out. 1s2, 2s2, 2p1, 2, 3, 4. And we did that in a previous assignment. How about one of these? Let's do the very first one. Find the mass ratios and atomic ratios for the following compounds. PCl3. Oh boy. Well, the atomic ratio is easy. It's 1 phosphorus. It's 1 to P:(C) equals 1:3. In other words, a ratio of phosphorus to chlorine atoms is 1 phosphorus atom for every 3 chlorine atoms. But the mass ratio is not as easy. Let's estimate the average atomic mass and divide up the pi. So listen to how I do this. Going back to our periodic table. Phosphorus checks in at 30.97. Yikes, I'm going to call that 31 to make my mass easier. And chlorine is 35.5, which is always a little bit annoying. See that? 35.45. Okay, let's see if I can add these up. I'm going to call it 35.5. So 2 is 70. 3 is 105.5 plus my 31. I think I got 146.5. Yeah. Assuming that's correct, and then forgive me if it's not. Just you can always just ask Google, hey Google, what's the molar mass of PCl3? But I got 146.5, of which most comes from chlorine, right? But how much comes from phosphorus? Well, 31 of the 146.5 are from phosphorus. Therefore, it's like a grade on a test. 31 divided by 146.5 times 100%. I'm going to guess that's pretty close to a fifth, maybe a little bit more. So you'll probably get a number of like, 21%, something like that. And that's how you do those. Formulas, not too bad. Sodium chloride. Well, let's take a look. Sodium, Na, chlorine, Cl, therefore NaCl. It's not really that easy though, because the charges always need to offset. Salts need to be stable, meaning that they have no charge. Therefore, sodium always forms, check that out, a +1 charge. Chlorine always forms a -1 charge. I typically go to the trouble of writing the +1 over the sodium, the -1 over the chlorine, and then check that it's stable. So that's NaCl. Why don't we do one that's a little tougher? How about, calcium nitrate? Oh, that's a good example, one where there's a few things going on. All right, so I'd start by finding calcium. And there it is. So I'd write a Ca. I'd write a +2 above it. And then I need to find a nitrate. So I'm looking around for the element called nitrate, and I can't find it. Reason? These are always ions, right? The calcium ion, the other ion. They're not always elements. They can be polyatomic ions. And typically if they end in something different, right? Not IDE, but nitrate, right? It just doesn't sound like an element, and it's not. So we'll look it up alphabetically in our little polyatomic ion sheet. Oh, there it is, NO3-. So far I've written Ca with the +2 over it, NO3 with the -1 over it, and something is rotten in Denmark because those charges don't offset. This thing would be +1. How do I solve that? Well, I could just think about it and say 2 nitrates should do it, and it does. So I would write Ca and indicate 2 nitrates. I think the only way to do that is use parentheses. An old teacher used to say, wrap your radical. I don't use the term radical. I think of a radical as a very different thing. But Ca, parentheses, NO3, how many of them? 2, that would be a subscript. There's also a shortcut for that, and it's called drop and switch. You see that 2, at least I see it in my mind, above the calcium. You see the 1 over the nitrate, switch them over. The calcium gets the 1, so that makes sense. The nitrate gets the 2, and that's kind of a quick way to do it as well. Okay, how about maybe, what did we do? We did one of those. Is it done? No, there's another sheet. There's magnesium chloride done for you, so why don't I help you and do a different one? Wow, Al2O3, if we can do that one, that should work out. Oh, and it just asks us to name it. Now, the rule for naming ionic compounds, which almost always means a metal followed by non-metal, and you can recognize a metal because it's left of the staircase, but we don't use monodi-tri. We don't say monosodium monochloride, right? And even for, calcium chloride, it's CaCl2, see that one? But we don't say calcium dichloride. It's just the way we say these things. It's not necessarily systematic, but it's what developed. So we're not going to say dialuminum trioxide. We'll simply say aluminum oxide. Okay. Similarly, these ones are conveniently all to the right of the staircase. Check it out. You'll see that it's true. They're not metals. They're simply covalently bonded substances. Now we do use the monoditride, right? Carbon dioxide, for example. We don't just say carbon oxide. So let's just do one of these. That is carbon 40 is carbon tetrachloride. And finally, let's try to do some formulas. Well, this doesn't look too bad. This just tells you how many to do. Carbon tetrafluoride would be CF4. What else? Hey, we're done. Okay, I hope that's a little bit of assistance with this particular assignment.